Good morning, everybody, and welcome back to Next Door NetAdmin. Have you ever thought about the kind of network a network admin might have at their home? Do you think it would be big and complicated like what they have to deal with at work all day? Or do you think it might be more simple and plain so they don't have to put too much time into troubleshooting and maintenance outside of work? I don't think there's any one way that goes. It probably depends on that particular network admin. But I'm going to save you the effort of speculating about my home network because that's what prompted today's video. Now, while I essentially have a section of this house to myself and my own family, I do share the house as a whole with several other people. Most of us are what some might call tech heads. In fact, the owner of the house is also an IT administrator. Sometimes he and I agree on what we'd like to do with the network. More often, we have slightly different ways of approaching the same problem, and we use somewhat different equipment. We're good friends, he and I, but we still see things differently. Last week, I was working away down in my home office, and I got a telegram from somebody upstairs, asking if I knew a lot about the wireless network. My answer was that I knew a bit about how it was constructed, but I hadn't gotten into the specifics, because we use different brands of equipment with different ways of configuring it. Turns out there was a wireless network issue upstairs, and they were worried because my friend, the IT administrator, was getting super stressed out about it. So I wandered upstairs to ask how everything was going, nice and casual like. I got snapped at, something fierce. Curses were uttered, mostly directed at systems I had suggested. Demands were made to know why I was there and what I wanted, etc. I gently suggested that I was there because I came up to say hi and see how he was doing, and clearly it looked like he could use a break from whatever was frustrating him so much. So I offered to take over the troubleshooting. Yes, I have the equipment downstairs to power it. Yes, I have ports on his VLAN. I am a network admin after all. So I gently relieved him of the problem equipment and brought it downstairs to work on, and I had it fixed in about 20 minutes. The upstairs wireless is based on Unify. I consider the equipment to be unreliable, cheaply made, and poorly designed. But the salient point here is that it uses a network controller to manage the access points, or APs. My friend was in the process of migrating from one network controller to a newer one on a different system, and he couldn't get the access points to come up on the new controller. He'd even gone so far as to factory reset one, turn off the old controller, and it still wouldn't show up as available on the new controller. Like I said, I have not used this particular brand of controller more than a handful of times, but I do understand some principles of their function. There's a common problem all network controllers like this face, which is how do the APs know where to find their controller? And a common problem tends to have a common solution, which I have used before with other systems. In brief, most controller-based systems will have a method of announcing their presence on the network, and they hope that the APs find it that way. I'm not going to go into that particular method too much, but this usually takes place at layer 2 in the OSI model. But that's a default method, and it can be explicitly overridden by a couple of administrator-controlled methods that can tell the APs where to go. Those are DHCP and DNS. The DNS option is simplest. You just have to create an A record, or sometimes a CNAME record, that points to the controller. Once the AP has an address and DNS servers, it can look up the name and get pointed to the correct controller. DHCP is trickier because it relies on option 43, and that can be frustratingly difficult to get working. Well, I checked, and my friend wasn't using either of these methods to point the APs in the right direction. The default method clearly wasn't working for the new controller, so I figured I'd have to set a method to explicitly tell the APs where to go. I didn't have access to modify his DNS settings, but I did have access to DHCP on his network. So, what is DHCP option 43? The Dynamic Host Configuration Protocol, or DHCP, is a standard method of allowing machines to request an IP, or Internet Protocol, address from an administrative server on the network. With that address, DHCP also allows machines to request many different options, things that aren't strictly necessary to know, but can be really, really useful if you have them. For example, the subnet mask is optional, not mandatory. That's option 1. Option 3 is a router. Option 6 is name servers. Option 15 is a default DNS domain. There's lots of options. The spec for DHCP says that any vendor-specific information should go into option 43. So why is this so tricky? Well, the problem here is that all vendor-specific information goes into option 43. There's no rules about what that information can be or should be. The spec also allows you to put multiple pieces of information into option 43, up to something like 250 different pieces of info or thereabouts. And how that is interpreted will be different for each manufacturer. That means that when you program a DHCP server with option 43, there's no rules. Everybody knows that option 3 is a router IP address, so they make an interface that lets you put in an IP address, and the server translates it to the correct format as required by spec. But option 43 is so freeform, there's no rules for how the information you type in gets translated to the final result. That means every DHCP server handles it differently, so you have to figure out how your specific DHCP server translates the information for your specific brand of equipment. In this particular case, the DHCP server had an option for IP address. Cool, so I tried it. Didn't work. I guess that would have been too easy. So I had to dig into the specifics of how Unify expects their option 43 to be served to them. Now, I mentioned that you can put in multiple pieces of info into option 43. Because of this, Unify is actually looking for not just option 43, but sub-option 1. There's no standard way to indicate sub-option 1 on a server, but if you understand how the actual data is sent on the wire, you can backtrack to the right format. First thing we should understand here is how IP addresses are represented to a computer. You're probably familiar with a basic IP address like 192.168.1.10 or 10.0.0.1. These are sometimes referred to as dotted decimal addresses, and they're pretty common for 32-bit addresses such as we find in IP version 4. But these are explicitly translated to be human readable, and that's not how the computer sees it. Each dotted section in one of these addresses corresponds to a single byte of data. 8 bits makes 1 byte, so a 32-bit address is 4 bytes. Each bit can only be 0 or 1, so you need 8 of them to make a number as big as 255 in base 10, or decimal, our regular way of representing numbers. But there's another way to view these numbers. If you go all the way up to base 16, or hexadecimal, you can evenly represent 4 bits as a single character. We only have 10 numeric digits representing 0 through 9, so we add letters to make up the other 6 values, starting with A for 10 up to F for 15. Then when you wrap around, you wind up with 10, a number we would read as 10, representing 16 in hexadecimal. I know, it just can melt your mind. The key point here is that this is what we need to see in our final option 43 output. Subtype 1, length 4, because we have 4 bytes of IP address following, and the address of the controller. we represent this in hexadecimal, which will be translated to binary on the wire. So let's say our controller is at 10.1.2.20. What do we need to output? Suboption 1, so 0, 1. Length 4, so 0, 4. 10 is 0A in hex. 1 is 0, 1. 2 is 0, 2. And 20 is 1, 4. Our option 43 value needs to be 0, 1, 0, 4, 0A, 0, 1, 0, 2, 1, 4. Now, how you represent that is different for every DHCP server, like I mentioned. In Windows, you have to set this as binary data, even though it's actually hexadecimal. Some other DHCP servers will call it hex. Some require you to enter it as a string. Some need additional values so that it only sends this particular option 43 value to devices of the correct brand. Here, I will say that Google is your friend. It's going to be a lot faster to find the format you need than to try and determine it experimentally. In the end, I was able to set up DHCP with option 43, and the access points for the upstairs wireless network were able to be moved into the new controller. Happy endings all around! I still don't necessarily agree with the choice of equipment, but the important thing is that I was able to help out a friend and save them a lot of stress and early hair loss. Hope you enjoyed this little glimpse into my home networking life. I am your next door net admin. Thanks for joining me.